So this question that we have in front of us is one of the questions from this week's lecture, but I figured I would do it in Excel as well, just to show you in Excel and a spreadsheet how you can calculate out all of these different probabilities step by step. So one more time, Brad Williams is the owner of a large car dealership in Chicago, and he has an incentive compensation program which compensates employees based on their performance. He offers an annual bonus of $10,000 for superior performance, $6,000 for good, $3,000 for fair, and 0 for poor. And there's no lock into how many people can have each individual classification. I mean, if the sales staff does an outstanding job, they could all be superior. If it's a terrible period, they could all be poor. But based upon his prior records and his expectations, Mr. Williams believes that 15% of employees will have superior performance and get that bonus. 25% will have good performance and get that respective bonus. 40% will have fair performance, and 20% will perform poorly. We need to calculate our expected value. And to find your expected value, you take each of the individual outcomes, or x of I, if you will. So for us, what are the outcomes? That there'd be a $10,000 bonus, that there would be a $6,000 bonus, that there would be a $3,000 bonus, and there's no bonus. Those are the 4 levels of compensation that our employees can get based upon their performance. What's the probability that what happens is going to be equal to that possibility, that our x is going to equal our xi? Well, for superior performance, we said that there's a 15% chance. For a good level of performance, we said that there is going to be a 25% chance. For fair performance, there's a 40% chance. And for poor performance, there's only a 20% chance. And you can check to see if that is exhaustive. It's the sum of all of these numbers over here, and we add it all up, and it is. That's all of the different conditions that we can have. It covers all of our probabilities. So now what we want to do for each one of these is multiply that x of I, that potential outcome, by the probability that it occurs. So 10,000 times 15% comes up to be $1,500. On the next line, 6,000 times 25% will also be $1,500. Over here, 3,000 times 40% comes out to be $1,200. And 0 times 20% is going to come up to be another big fat 0. So what is the expected value of the annual bonus for any one particular salesperson that we have on our staff? It's just the sum of all those numbers. $4,200 is how much we can expect to pay on average to each one of our 25 employees for their bonus during the period. What amount of variation do we have? What we're going to do now is figure out how far each one of these points is away from our expected value, and then we're going to square it. And we're going to multiply that by the probability of the event happening. So over here, the first outcome we have is that it is 10,000 minus the 4,200. That one's $5,800 away from our x of I in this case, or from our expected value that x of I is. I'm going to want to fill handle this, so right now I'm going to make that second cell absolute. We want to, as our formula says, square this. So to do that, I'm going to hit Shift and 6 to put the caret in, and then put a 2, so 2 to the second power. And then we're going to multiply that by the probability of that event happening, which is, in this case, 15%. And we come out with a huge variance of that of a little over $5 million. And with the way that that was inputted now, I can use my fill handle to change, because the way the formula is set up right now, if I bring it back up again, this wasn't made absolute, so when I drag down 1, it's going to drag this down 1. This wasn't made absolute, so when I drag down 1, it's going to drag this down 1, which we want that 6,000 times the 2,500, but because cell C12 right here is absolute, it's always going to use that in our formula. So now I can go, and I can fill handle that all the way on down my 4 lines, and one more, and I get the variance for each individual outcome that we have. So the total variance of our bonus is just going to be the sum of all of these numbers. And again, variance is not a great measure because its number is distorted a little bit by the measurements of what you're doing. Like, we can go up to $10,000 and it makes this variance look huge. If it was only a potential for a $1,000 bonus, it would look much smaller because this is getting measured in terms of dollars and it's not working out for me. Standardizing this makes it a much easier number to grasp. So what I want to do is take the square root of this number. And in Excel, you can do that with the square root function, which you can find with SQRT. And we want that guy. Yep, so I'm going to hit OK. And all I got to do now is just click on the number I want the square root of, which is 9,960,000. Now we come up, rounded off to the nearest dollar, of $3,156 is our standard deviation, which means 2/3 of the time, each individual person, or 2/3 of our employees, will have a bonus that's somewhere between 3,156 less than our 4,200 expected value and 3,156 more than our expected value. Or if you want to say it in numbers, we can say that 67% of our employees are going to receive a bonus that is somewhere between $1,044 and $7,355. That's a huge change right here. So going off of this expected value right here isn't a great way of going about how much we're going to pay each employee individually, but we're hoping that with a sample size of 25 employees that the extremes even out. That some employees are going to have somewhere around $1,000. Some employees are going to have somewhere around $7,000. So it should average out to, on average, an expected value of $4,200 per person. And the bigger that employee base is, the better this works based upon the standard deviation. But let's just go with this expected value of $4,200. If that's what we're expecting to pay each and every employee, and we have, as the information tells us, 25 employees, that means that when this particular company is budgeting for how much it's going to have to pay employee bonuses for the period, this large car dealership in Chicago is saying that they should be expecting to have to pay out $105,000 in total to all of their employees. Let's do one more on the publishing tab. And for the publishing tab over here, we are the manager of a publishing company, and we plan to institute a plan where the company's sales representatives are rewarded based upon their respective sales figures for the year. This plan calls for a bonus of $20,000 to the top 15% of its sales representatives. So hypothetically, we have 100 employees. The top 15 that makes the most sales will get a bonus of $20,000. There's a bonus of $10,000 to the next 30% of sales representatives, a $5,000 bonus to the next 10% of sales representative, and the bottom 45% of our sales reps do not get a bonus at all. Very interesting setup right here, though, because there is no variation. They're competing against each other. 15% is always going to get this. 30% is always going to get $10,000. 10% is always going to get $5,000, and 45% is going to get no bonus at all, which means we won't have a standard deviation. Everything is contingent upon something else. The total amount of this is going to be exactly what we're going to have to pay. So let's figure out what our expected value for any one employee is going to be. And our outcomes, as we have above, is that some people are going to get a $20,000 bonus. Some people are going to get a $10,000 bonus. Some people are going to get a $5,000 bonus. And 45% of our sales staff isn't going to get a bonus at all. And let's fill in those percentages to get that bonus each time. So 15%, 30%, 10%, and 45%. Now, to figure this out, what our expected value is, we first take the individual input and the probability of it happening, multiply them together. And I can just fill handle now to fill in all these columns. And I can sum those up to get the expected value. What we expect the bonus to be for any one employee within our staff, and it's $6,500. So with that, we can take that $6,500 and we can multiply that by the number of employees that we have. And down here in B, it's telling us to determine the total amount of expected bonus the company will pay to its 2,000 sales representatives at the end of the year. So 200 employees. And if I go and I multiply that by this, $6,500 per employee times 200 employees, we come out to be $1.3 million. So I stated at the beginning that there would not be any standard deviation to this problem, and I can prove it in numbers. What we're saying right here is the bonus is going to be 1.3 million overall based upon our expectations. I can prove that in numbers. We have 200 sales representatives on our staff. I'm just going to throw that number in right here. It's not like all 200 of them can get the $20,000 bonus. Only the top 15% can. So how many employees would get that bonus out of the 200 if only 15% can? Well, I can go and I'll put it right here. Multiply that 200 employees times the 15%. That means only 30 people are eligible to get that level of bonus in this instance. And I'm going to go back into this formula right now and make that 200 absolute real fast so I can fill handle one more time. There we go. And with that same set of numbers, if 30% of our employees are going to get a $10,000 bonus, well, 30% of those 200 employees is 60 employees. If only 10% of our employees are going to get a $5,000 bonus, well, 10% of the 200 employees would be 20 employees, and the 45% that don't get a bonus, 45% of our 200-person sales staff, is 90 employees in this instance. How much would we pay out in total? Well, these 30 people, the top 15%, would each be getting a $20,000 bonus. So if we're paying 20 grand to 30 different people, that's $600,000 in total that we have to pay. Down here, 60 people would be getting a $10,000 bonus. Let me just fill handle because it's going to work for me right there. So that's another $600,000. 20 people would be getting a $5,000 bonus. So 5,000 times that 20 is going to give me $100,000. And the last 90 people are going to get no bonus whatsoever. And what happens when I sum that up? The math checks out. That is the 1.3 million that we said it was the expected total bonus. So due to the very particular nature of this bonus structure, there's no variance. There's never going to be a situation where these numbers, the proportion of our 200-person sales staff, change. They're in competition with one another to get all of these bonuses. This is different from the dealership tab over here, where any person could get any one bonus based upon what they do during the period. So if you're a manager and you're budgeting for bonuses, making your employees compete against each other reduces the likelihood that you're going to budget for a number that's way off of what actually happens.